This rhombus is mainly used for decision making or branching purpose. We are using this rhombus shape. If this is the condition, then it will display A is largest, otherwise it will display B is largest. This is the algorithm. Finally, we have to stop. We are taking input as well as for output purpose. We are taking parallelogram symbol. For calculation purpose, rectangle symbol. For decision making, rhombus symbol. Finally, we will stop. Welcome back to one and all. Myself, Vasanta, lecturer in computer science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we are going to start with the second session of problem-solving methodology. Whereas in the previous session, you have studied regarding the introduction regarding problem-solving methodology. With that, the stages of problem-solving process. Under that, what do you mean by problem definition? That is nothing but identification of the problem. Then problem analysis. That is, here we have to identify the requirements of the problem. Then design of a solution using algorithm and flowchart. We will represent that problem in the format of algorithm as well as flowchart. Whereas algorithm is nothing but step-by-step procedure to solve the given problem. Whereas flowchart is a pictorial representation of an algorithm. Then the next one is coding. That means whatever algorithm as well as flowchart we have, converting that into any programming language, where it may be C, C++, any programming language, converting that code, especially here the designs, that is algorithm and flowchart into programming format. Then program testing and debugging. After writing the code, we will check whether the program is working as our requirement or not by giving sample data. That is nothing but testing. Whereas debugging is nothing but correcting the mistake. It can be called as debugging. And the next stage is documentation as well as maintenance. Here, documentation is required for future purpose. Maintenance also, we have to maintain the whatever program we have done, that has to be maintained. These are the few stages of problem solving methodology. Whereas on today's class, you will come to know regarding different types of symbols used in flowchart. Then analysis of algorithm. If I want to write any algorithm, what are the rules and regulations here we have to follow? That is, what do you mean by worst case? What do you mean by best case? When we say it is an average case, how to write an algorithm as well as how to write a flowchart. Regarding that, you will come to know on today's session. First, we'll discuss about flowchart. What do you mean by flowchart? Flowchart is nothing but it's a pictorial representation, or I can say it is a graphical representation of an algorithm. By using some special symbols, we are writing the program here. The instructions are written here. Whereas it is a diagrammatical representation of solution to a problem. Whereas it uses geometrical shapes to represent sequence of instructions. Some particular geometrical shapes are used. Now one by one we'll discuss. First one, in this, if I want to write any flowchart, then some specific symbols only to use. The first symbol can be called as oval, and this is the shape, that is a symbol to represent start as well as stop. If I want to start any algorithm, then compulsory have to use the oval shape. And the second one is parallelogram. This symbol, especially parallelogram, is used for input as well as output purpose. When you want to input some data or when you want to display some data information, on that time we need this parallelogram. And the next one is rectangle. Here, for processing purpose as well as for calculation purpose, we are using this processor symbol, especially for calculation purpose. And the next one is preparation. Here, this symbol is for looping purpose. When you want to perform some statement has to be performed repeatedly, then we are using this for looping purpose. For example, I want to display some information from 0 to up to 10 times. On that time, we are using this looping concept. Next, here we have the symbol rhombus. This rhombus is mainly used for decision making or branching purpose. We are using this rhombus shape. Compulsory, this rhombus shape is used for decision making purpose. And the next one, predefined processor. This is a symbol for predefined processor. When you want to write subprogram, on that time we are using this predefined processor. And the next one is connector. When you want to connect from one page to another page, then we are using this connector. For connection purpose, we are using this circle shape. And the next one is arrows. Here this arrow will tell you on which direction the data is moving or which direction the control is passing. For that purpose, we are using this arrow symbols. Then which are the symbols? For start and stop, for input as well as output purpose, for calculation purpose, for looping purpose, for repetition purpose, that is for looping purpose, and this rhombus symbol for decision making. When you have some conditions, for example, A is greater than B, on that time we have to make some decision. On that time we are using this rhombus symbol. And when you want to write some subprograms, then we are using this predefined processor, and this is for connection purpose, and this is for controlling purpose, on which direction the data is moving, the control is moving. To represent that, we need arrow symbols. Now, is it clear? Now, we will explain some flowchart as well as algorithm. For example, first I will write the algorithm. Write a program or write an algorithm, the value of a two variable. I just want to swap or interchange the value of two variables. On that time, how to perform? Consider we have one box A and one more place, memory B. Consider in the first place I am having the value 5, in the second place I am having the value 6. Here we are interchanging the value. Directly we cannot shift this B to A and A to B because already some values we have. For the sake, first phase what we will do, we will take the temporary place. On that case, what we will do, first whatever value in A, that we will move to temporary place. Now this place become free now. Once if I shifted the A value to temporary place, now A place is free. Then afterwards, whatever B value here we have, that we will move to A. Once if I moved, now this B value is free, that particular place is free. Then afterwards, whatever variable, whatever value in the temporary place we have, that we will move here. Now this place become free. It means that swapping or interchanging the value of two variables. For that, we will write the algorithm as well as flowchart now. See, first, as usual, in first step, we have started. If I want to swap two numbers, interchange two numbers, then we need the variables A and B. That we will input A as well as B. Then if you observe in the processing stages, first whatever value in the A, that I will move to temporary place. Usually, if I have temp equals A, the right side value, whatever we have, that will move to left side. First place, whatever thing in the A, that I will move to temporary place. Now this place become free. Then later on, whatever value in B, that we will move to A. Whatever value in B, that we will move to A. After that, whatever value in the temporary place, that we will move to B. Whatever value in the temporary place, that we will move to B. Whereas this can be called as assignment operator. Here, whatever value, for example, if you have A equals B, it means that whatever value in B, that will move to A. This can be called as assignment operator. Here, the swapping will take place. After swapping, it will display the value. In the beginning, the A value is 6, A value is 5, B value is 6. After swapping, A value is 6 and B value is 5. That is nothing but here we will display A and B value. Finally, we will end. This is the algorithm to swap two numbers. In the same way, if I want to write the flow chart, for that, first as usual, you have to start. Already I told you the symbols. Here for start and stop, we are using oval symbol. Here start, the same thing, whatever algorithm we have, just we are replacing that in pictorial graphical format. First step, we have started. Then second step, input the values. Here whichever values we have, that we will input. For input purpose, we need this parallelogram shape. Compulsory for input purpose, we have to use the parallelogram shape. For calculation, the rectangle shape only you have to use. Now here, we will input A and B value. Afterwards, we will perform the calculation, the same pattern. Whatever value in A, that we will move to temporary place. Then afterwards, whatever value in the B, that we will move to A. Then finally, the temporary value will move to B. If you want to remember, see, here A and A will be common, here B and B will be common. First and last will be temp. Like that also you can remember. Then after swapping the value, we have to display the output. That means input as well as output. For that purpose, we are using this parallelogram symbol. Then display the output A and B, finally stop. This is the algorithm and this is a flow chart to interchange the value of two variables. Next, one more flowchart and algorithm we will explain, that is find area and circumference of a circle. I want to find area as well as circumference. What is the formula to find area? The area formula is pi r square and circumference value is 2 pi r. This is the formula you know. Then how to calculate this? First step as usual start. Whereas algorithm is nothing but step-by-step procedure to solve the given problem. Then here if I want to perform area and circumference, only we need r is the input variable. That's why input r. If I'm going to give r value, then I can able to find area as well as circumference. That's why input r. Then the calculation, that is area equals pi value is 3.14. Standard value, that here we'll write pi r square. 3.14 into radius. Then circumference equals 2 pi r, 2 into 3.14 into radius. Now here we are done the calculation for both area as well as circumference. After that, we will display the value of area as well as circumference. Then finally stop, or I can say it as end of that algorithm. This is the algorithm to find area as well as circumference of a circle. Now, if I want to write a flow chart for that, see, first step, as usual start. Here also we have started by using oval shape. Then input the value radius. Here we are input radius. For radius, it is an input operation. Then compulsory, you have to write that with a parallelogram symbol. Then calculation. For that you have to use a rectangle or a square box you have to use. There, the formula area equals pi r square, that is 3.14 into radius into radius. Then circumference equals 2 pi r, that is 2 into 3.14 into 2 into radius. Then here output the result, that is area and circumference. Here we have done the calculation of area as well as circumference, that here we are displaying output. To display the output, we need the parallelogram symbol. Both for input as well as output, we are using parallelogram symbol. For calculation purpose, rectangle symbol. Then finally, we will stop that. This is the flow chart to find area and circumference of a circle. Here, for example, if I want to find greatest of two numbers, then further the algorithm is first as usual, we have to start, then input A and B. For example, consider you have two memories, one is A and one more is B. Two memory place, here I am having 5 and here I am having 6. Then what is the agenda of this algorithm as well as program? You have to identify which is the largest number, A or B, that you have to identify with the help of algorithm as well as flowchart. Now for that, if I want to find the largest of two numbers, then first I have to input A and B value. Then later on, if A is greater than B, I have to check. If this A is greater than B, then it has to display that A is largest, or it has to print that A is largest. If this condition not satisfied, then here it has to display that. Here we have else on that time you have to display B is largest. If this is a condition, then it will display A is largest, otherwise it will display B is largest. This is the algorithm. Finally, we have to stop. This is the algorithm to find largest of two numbers. If I want to make any decision, then compulsory we need rhombus symbol. Here first as usual we are going to start by using the oval shape. Then input the variables A and B, whatever values we have, that you have to input by using this parallelogram shape. Then afterwards we will apply the condition if A is greater than B. If this is true, then it has to display that here we have written T. It means that if A is greater than B, then it has to print that A is greatest or largest. See, Here I'm having, for example, A 6 and here B 5. Then this condition satisfies. On that case, it will display A is largest. Otherwise, if this condition not satisfy, that is false. If it is false, then it will print that B is largest. Finally stop. It means that for decision making, we need rhombus symbol. In the rhombus symbol, we have two options. One is true value as well as false value. If condition satisfy, one statement it has to display. If the condition not satisfy, another statement it has to display. This is regarding flowchart to find largest of two numbers. Next, we'll discuss about the algorithm to find factorial of a number. What do you mean by this factorial? Here, for example, if I'm going to give 3, then 1 into 2 into 3 it has to find out. For example, if I'm going to give 2, 1 into 2. If I'm going to give 3, what is the factorial of that 3 is? 1 into 2 into 3. This is the factorial for 2 and this is a factorial for 3. If I want to find the factorial of 4, then how to find 1 into 2 into 3 into 4? That is nothing but factorial. Some values we want to repeatedly execute and we have to do the calculation. Here for that purpose, as usual in the algorithm, we will start. Then input the variable. For which variable we are finding the factorial, whether for 1 or for 2, 3. For which variable you want to find the factorial, input that. In the beginning, we will assign fact equals 1. Here, first we will assign the fact equals 1 in the beginning. Then the remaining value one by one, the calculation has to be performed. See, fact equals 1 we have to initialize. Then repeat for I equals 1 to n. Till which number we are given? Till that it starts from 1 to n. That is till the last number. Fact into 1. That is fact into here I we are given. It means that here in the beginning case fact value we are given 1 into 1 it will perform. Then once again it will go back to the loop into 2. Then once again it will go back to the loop into 3. It means that how long the n number are given, till that this loop will continue, finally end of for loop. Then in the next step, we will stop processing, output the factorial and then we'll stop processing. But when they come on flowchart, here first start, then input n. For which number you want to calculate, input that n. Then fact will assign it as 1. Then for I starts from 1 to n. Then here until I is less than or equals to n, till that it has to find the factorial. Here if it is true, it will find the factorial. If it is false, it come out from the loop. It means that as long as the condition satisfy, it is true, till that it will find the factorial. That is fact equals fact into I. Then finally stop. Next we'll discuss about the algorithm to generate Fibonacci series. What do you mean by this Fibonacci series? Whatever number we have, the previous two numbers we have to add. First compulsory 1 and then 2. Next case, add these two values, that is 2 and 1, 3. Next case, 3 and 2, that is 5. Next, 5 and 3, that is 8. Next, we have to add the previous two values to get the Fibonacci series. For that, first step, start, input n. For which number you want to find the Fibonacci series? Then compulsory first time we have to initialize it as 0. Then next 1. Compulsory you have to initialize the first one is 0 and the second one is 1. Then in the next case you have to add 0 and 1, 1. Next 1 and 1, 2. Like that, one by one we have to add. Print first and second value, that is it will print 0 and 1 first time. Then third value, add the first and second value, whatever value here we have, this one as well as this one we have to add, then we'll get 1. Then repeat while term is less than or equals to n. Till how long I given n? Till that this process has to be repeated. Print the third value. Then afterwards we have to interchange the second value to first value as well as third value to second value. That is, we have to add these two values. Now we'll get 2. Then third value equals first plus second. Then once again the term will increment here. The term equals term plus 1. Like this loop will continue. How long? The n we are given. That means Fibonacci series is nothing but display the value previous two values it will add and then it will display the result. Then for this, if I want to write the flowchart, then first as usual, first we will input n, then first value initialize it as 0, then 1, then next after that the term we will write one by one. Print the first and second variables, 0 and 1 it will display. Then third variable equals first and second, these two value we have to add, then once again we will get 1. Then term, here if term is less than or equals to n, till that the swapping of number will take place. That is, it has to print the third value, first equals second, and here second equals third, and third equals first plus second we have to take, then increment the term. This loop will continue as long as the term is less than or equals to n. Then once if it is false, then it will come out from the loop here. Whereas here if you observe, here for input purpose, we are taking input as well as for output purpose, we are taking parallelogram symbol. For calculation purpose, rectangle symbol. For decision making, rhombus symbol. Finally, we will stop. Now is it clear? Next, when we come on analysis of algorithm. Analysis of algorithm. It means that till now you have studied few algorithms as well as flowchart. How to write algorithm for a given problem and how to write the flowchart for a given problem. Now we'll explain how to analyze or analysis of algorithm. Whereas there may be more than one approach to solve any problem, more than one approach to solve a problem. The choice of a particular algorithm depends on the following performance, analysis and measurement. If I want to write any algorithm as well as flowchart, then I have to check for time complexity as well as space complexity. What do you mean by space complexity here? How much space we require to write that algorithm as well as flowchart. That also we have to keep it in our mind. Then how much time is required to complete that task. That also we have to keep it in our mind. When we say it's the best case, when we have minimum number of time as well as minimum number of space, then it can be called as best case. Worst case, when we have maximum number of time as well as maximum number of space it requires, then it can be called as worst case. Whereas here, space complexity is nothing but the amount of memory, how much space is required, the amount of memory needed by the algorithm to complete its run operation. To complete that, how much space we required. But when they come on time complexity, the amount of time, how much time we required to complete the algorithm, especially needed to complete its run operations. This is nothing but time complexity as well as space complexity. If I want to write any algorithm, these two complexity I have to check. One is how much space it requires and one more is how much time it requires. Next, when we come on this, we can have following three cases of algorithm based on input data. One is best case, average case as well as worst case. When we say the best case, minimum number of time as well as space, then it is a best case. When we say it's a worst case, when we need maximum number of time as well as maximum number of space, when we need on that time, then it can be called as worst case. Whereas average case is nothing but here it's average number of space as well as time if it is required, then it can be called as average case. First, one by one we'll discuss best case. The amount of them a program might be executed to take on best possible input data. Whereas average case means the amount of them a program might be executed to take on typical input data. And the last one, the worst case, the amount of them a program might be executed to take on the worst possible input configuration. Worst time as well as large time space when we required, then we used to call it as worst case. When we say best, minimum number of time as well as minimum number of space if it requires. These are the things regarding on this class. That is, what do you mean by time complexity, space complexity, then what do you mean by best case, worst case, average case. The next class, you will come to know regarding the programming construct, like what do you mean by if, selection construct, if statement, if else if, nested if, as well as switch. What do you mean by for loop, while loop, how to write while loop, for loop, as well as do while loop. Regarding that, you will come to know in the next session. Thank you for all of you.